We now know that the net force on an object is the sum of all of the forces acting on it. We know that if the net force equals 0 newtons, then the forces are said to be balanced. But what would happen if the net force was not 0 newtons? We'll look at a situation that we looked at in balanced forces, where we have a rider on a bicycle. And when we were looking at balanced forces, we looked at the force due to gravity, which was 500 newtons in the downwards direction. And that was being balanced by a force of 500 newtons in the upwards direction due to the ground pushing the bike and the rider up. We also looked at a frictional force which was trying to stop the motion, which was 750 newtons. And to balance that frictional force, the rider was applying a forwards force, or a driving force, of 750 newtons in the forwards direction. When we added up all of those forces, we ended up with a net force of 0 newtons, which meant that the motion of the bike remained unchanged. What if, though, we increase the driving force? So you'll see in this situation that the gravitational force down here is still 500 newtons. The normal force pushing upwards is still 500 newtons. The frictional force is still 750 newtons, but what we have done is we have increased our driving force to 1000 newtons. So the vertical forces in this case are still balanced. We still have 500 newtons up, 500 newtons down. The effect of both of those forces will cancel each other out. But the horizontal forces are no longer balanced. So when we have a look here, we can see that the driving force over here is a larger force than the frictional force over here. So we now say that these forces are unbalanced. So the question is, what will happen to the motion of the rider and the bicycle now that we have unbalanced forces? To find this out, we need to determine the net force that is acting on the rider and the bicycle. So if we just pull those two forces out, we still have 750 newtons to the left over here, and we have 1000 newtons to the right. And we can see that the force to the right is larger than the force to the left. So we would therefore expect that when we add these forces up to arrive at our net force, we would expect that net force to be directed to the right, because there is more force in that direction than what there is to the left. So we do a calculation. So our net force equals 750 newtons to the left plus 1000 newtons to the right, which will give us an answer of 250 newtons to the right. Now some of you may be wondering how we arrive at this answer of 250 newtons to the right. You remember before we mentioned that these directions here are very, very important when we're doing these calculations. So when we have a look at that, another way of thinking of it is to have a look at a number line. So we start with our forces here at 0 newtons. Here we have our 750 newton force to the left, which takes us to this point here, which we'll just call negative 750, because we're calling left the negative direction on this number line. From that point, we add our force of 1000 newtons to the right, and what that does is it gives us an answer here of 250 newtons to the right. So we have that net force 250 newtons to the right. This means that the rider and the bike will accelerate, and in this case that means speed up. So in the presence of unbalanced forces, motion will always change, and that means that objects could speed up, slow down, or change direction, and that is dependent on the direction of the net force, which is caused by the unbalanced forces.